Thank you once again for coming to this webinar. And I'll begin talking about the Carbon Connects peatland project. So this is an Interreg Northwest European Carbon Connects peatland project that we are working on. So this is broadly the outline of the presentation. We will talk firstly about the LIT and the development unit. We are the Irish partners of the EU Interreg Northwest European Carbon Connects project. We have other EU countries participating in this project as well, which I will talk about in the later slides. We'll talk about peatlands, as this is about peatlands. So brief introduction about what peatlands and its importance in this context of the climate change. Um, Going to introduce to all of you the EU Carbon Connects project, which we are working on, the major goals and the objectives. Will this rest of the presentation after will be focused on the Irish carbon activities are we doing at our pilot peatland site, and our collaboration with the Freshwater Pearl Mussel Project, IT Sligo, and the peatland landowner with whom we are working on. We'll share some of the activities that we are all doing in a team on the pilot site, share some preliminary results with all of you. And then, we have our Netherlands partners who have developed the computer simulation tool to quantify, greenhouse gas emissions from peatlands. So they'll be talking about it. And briefly, I'll summarize our activities and then conclude the webinar with the acknowledgements. So, as we have seen that we started with Dr. Darren Barry introducing all of us. So again, I'm Amay Tilak. I'm working with LIT. We have Dr. Derek with Freshwater Pearl Mussel Project, with whom we are collaborating. We have Poppy Overy. She's a PhD student at IT Sligo. She's working on vegetation and the beetles in the peatlands, and she's working with Carbon Connects and the Pearl Mussel. We have Dr. Jasper Van Bell, who is in VHL. VHL are our lead partners of the Carbon Connects, and they have designed the set emissions tool, which Jasper will talk about in this presentation. So we are, once again, the Limerick Institute of Technology, the Irish partners of the Interreg Northwest European Carbon Connects project. We are hosted in the development unit in the Limerick Institute of Technology. So we broadly work on various projects ranging from sustainable energy to climate action to social enterprise to FOLUM. So we have different expertise in our development unit and working on different projects. Our climate action part is focused into two: the climate adaptation, which Dr. Darren Barry is working on, the EUCCC project, and the Carbon Connects, which is again a EU project which I'm working on. We all have been talking about climate change and greenhouse gas emissions and global warming, and we know that peatlands are a great mitigation tools. So they are great tools or great ecosystems to mitigate the greenhouse gas emissions, mitigate global warming. So if we look at the area of the peatlands over the entire globe or over the entire Earth's surface, they only occupy a very small percent of the area, roughly about 3%. But importantly, what they do is very important. They store twice more carbon in their soil and less in the atmosphere, and that means less greenhouse gases emitted. So but unfortunately, in the last several decades, in the EU and worldwide, the peatlands have been drained and burned for agriculture and horticultural purposes. What this has led to is large emissions of the greenhouse gases, three big greenhouse gases we all talk about and we all hear, carbon dioxide, methane, and nitrous oxide. So, peatlands are very important in this battle against the climate change, and there is a big need for restoring our drained peatlands and mismanaged peatlands in EU and the worldwide. So we are the EU Carbon Connects project. We are a Northwest European project. We began working in 2018 and will continue up till the end of 2021. So this project is very unique because it is resembling different peat types in different EU countries. So as you can see from this map, we have UK, Ireland, Netherlands, Belgium, and France. So these countries have different peat types, and we are working with all these EU countries having the different peatland types. And what you see from this figure is the pilot sites. Each country has got their own pilot sites, and we have common goals and objectives that we are working on our individual pilot sites. So the Valence Lodge pilot site is a UK pilot site. Our pilot site is near the city of Galway in Oughterard. Netherlands has got several pilot sites, and so has Belgium and France. So and we are working as a team together on this project. So coming to the goals, the major goals I would say of the EU Carbon Connects is to we are looking at enhancing the carbon sequestration of the mismanaged peatlands, the peatlands which have been drained. So we're looking at this. And the way we are looking at this is we are quantifying the carbon sequestration potential of those mismanaged peatlands on the pilot sites, that we are typically doing through some monitoring and computer modeling. Importantly, besides this, two important things we are doing besides looking at the carbon sequestration, we are promoting business models. So when I say business models, what do I mean? What I mean is we are promoting sustainable models on the peatlands, which provide a secondary income source for the landowners or the farmers who own those peatlands. So that's what we are working in the different EU countries. And we are also, again, working with different landowners and farmers. The goal is to conduct for these farmer to farmer sessions. The idea behind that is, how can we exchange ideas and best practices that might be happening in some other country and could be used in locally here in Ireland or in any other different place, and how do we exchange ideas about peatland restoration and peatland revetting and monitoring. So we are working on this aspect as well. So when I said in the last slide about the business models, different EU countries have their own business models. And here, as you can see on the screen, there is a brochure, a EU Carbon Connects brochure, which talks in detail about the business models. And you can go on and later see on the website. But I'll summarize briefly for you. The different business models which are implemented in Netherlands is they are working with the wet crops. So they are growing crops which are adapted to waterlogged conditions, waterlogged peatland soils. They are growing typha, they are growing the other crops. The utility of that is the harvested biomass from these crops has multiple uses. It could be used for biochar, biogas production. It could be used for composting, and some unique. It could be also used for making chairs, furniture, tables. So there are lots of income generating sources that can be derived from these business models. We in Ireland are looking at the ecosystem services. So we are working with the Freshwater Pearl Mussel Project in Ireland. So our business model is, can you have a good vegetated peatland which sequesters carbon, which holds the peat soil together so there is no erosion of the bare peat into your adjoining water bodies. so your water quality is not hampered. And at the same time, when we say pearl mussel, it needs waters which is devoid of sediments and nutrients for it to survive. And so it has multiple benefits, and then Dr. Derek will later on explain about in detail about this ecosystem services business model which we have in Ireland. So coming to our pilot site, as you can see, this is a map of the Ireland on your screen. So our pilot site is the red dot, which you can see from the screen. So it's on the western coast of Ireland, located near the city of Galway. So our pilot site, roughly the area of the pilot site is about 9 hectares. It's a mismanaged blanket peatland. The entire area of that peatland, which we are working on, is 137 hectares, but we are not working on 137 hectares. We are working on the 9 hectares, which is within the 137 hectare peatland area. And the important characteristic of our pilot site is it's located on the western coast of Ireland, which receives uh, quite a lot of rainfall, around 1,200 millimeters of the rainfall annually, compared to the Midlands or the mid region of the Ireland, which receives roughly around 800 to 900 millimeters of rainfall. So these blanket peatlands have formed in high rainfall and low evaporation areas. So our peat site is a privately owned land, the entire 137 hectares. And the peat cutting there stopped in 2016. And we, on this site, again, we are working with Freshwater Pearl Mussel and the IT Sligo. So we are very thankful to them for the teamwork. The characteristic of this pilot site is the pilot site has got the vegetation part, I would say, typically is a mixture of the bare peat surface and different kinds of vegetation. We have cotton grass, we have ling heather, and we have soft rush. So different types of vegetation in combination with the bare peat surface. And another important thing I would like to say is it's located in the Owenriff River catchment, which is a pearl mussel habitat. And that's why we are working there with the Freshwater Pearl Mussel Project. Now I would like to hand over the presentation to Dr. Derek, who is an assistant project manager of the Freshwater Pearl Mussel Project. And he will be briefly talking about the Freshwater Pearl Mussel Project and what it does. So over to you, Derek.
Thank you very much, Ame. First of all, can you hear me okay?
Yes, we can hear you, Derek.
Okay, fabulous. That's great. Well, thank you very much. I'm delighted to be presenting here. Delighted to be collaborating in the Pearl Mussel Project EIP with Carbon Connects. Just a very brief 2-slide background, I think, to put the Carbon Connects site into context. The Pearl Mussel Project is a European Innovation Partnership, EIP, Department of Agriculture funded project under the RDP, the Rural Development Programme. It's a 10 million budget. And our overall aim, our overall target is the conservation of freshwater pearl mussel. We operate in 8 catchments across the kind of the west coast of Ireland, from Donegal in the northwest all the way down to West Cork. And these catchments cover about 50,000 hectares or so. They're predominantly farmed. There's some forestry there as well. And the main farming practice is sheep, suckler, beef, cattle, and of course mixed sheep and cattle too. So the predominant habitats in these areas are peat-based soils. So you're talking about blanket bog, you're talking about acid grasslands as well. And as Ame said, these are very high rainfall catchments as well. So agriculture here is quite different to the Netherlands and quite different to a lot of Europe that has much lower levels of rainfall, maybe mineral soil, and maybe potential for other farming practices here. We started the project about 2 years ago or so, and the idea is to relate farmers' agricultural payments, agri-environment payments, these are the CAP payments as such, to the results on the ground. So it's a results-based project rather than a measures-based project, and I'll mention the difference in a minute. So our overall aim is the freshwater pearl mussel, but it's a long-lived species that lives in very, very clean waters, depends on pristine water quality, and it's very difficult to detect changes over a short period of time. It lives till 100 to 140 years or so. So we use a result indicator of the habitat quality. So our habitat quality is our result indicator, because we know that the better the quality, the habitat, the better the quality of the water that comes from that. And therefore, habitats are also an easy way to assess that quality. It's also in the farmer's control as well. So our payment levels to the farmers range depending on their score. Typically, each field that the farmer is holding is scored out of 10, from 0 to 10. There's no payment for less than a 4 out of 10, but the payments, as you can see in the top left of the graph, increase steadily to about a 6 or a 7, and then increase sharply to an 8, where we want farmers to be, and a further increase to a 9 and a 10 out of 10 for those. It's within the farmer's control. So what the effect that has is that it provides a market for biodiversity, I suppose. Now we have moved on and we have integrated, and we know that the better the quality, the peatland habitats, the better the services they provide in terms of carbon. The higher the sequestration, the better, and the better the storage of carbon and so on as well, versus a low peatland where you've got carbon loss, considerable carbon loss. So what we find that our ecological quality and the scorecards that we have for all of our farmers, and we have 35,000 hectares of with 450 participant farmers in it. So there's a considerable amount, is that their payments relate to the ecosystem services that they provide through carbon, clean water, and biodiversity. And of course, it all benefits our target species. So it's a very broad-based program. Now, we're delighted that one of our participant farmers has been chosen by Ame and his team to test their various experiments in terms of, from our perspective in the Pearl Mussel project, demonstrating and testing the correlation between our field score, and the carbon benefits. And then I suppose just very briefly, Ame, if you may just go on to the next slide.
Yeah. So,
and then very briefly, in many projects, there are traditional agri-environment schemes. We're looking at, people want to see, well, what have you done on the ground? But back to our scoring thing there as well, since it's results-based, the farmers know that their payments increase when there's better quality on the ground. We do have measures. We've got these, what we call supporting actions. So farmers have two budgets. They've got a results-based payment to get that relates to the quality on the ground. The better the quality of the peatland, the higher the payment that they get. So that really heavily incentivizes them. But we've also got an additional funding strand, and that's the supporting actions budget that farmers have. So if a farmer wants to improve their score and they've got some capital works, we'll say, to do, like drain blocking in this example, they can go ahead with training and support from ourselves to block drains, to reactivate these peatlands. So it's something that's very much farmer-led, when particularly, I suppose, the framework of the results-based approach, or even results and actions hybrid, it has this effect of self-incentivizing farmers to improve, to constantly improve, and to deliver the results. And they also get this inherent knowledge of what is happening in their sites as well. So it's in this context that Ame is working. He's assessing, which he's explaining at the moment. He is assessing a site that is on the ground before wetting, a farmer that's interested in improving his ecological score. and it'll be assessing the changes throughout that process. Thank you very much.
Thanks, Derek. Thanks for the introduction. So thank you very much for the great introduction to the Pearl Mussel Project. I guess so I'll again, I'm back again talking about the peatland site, the pilot site, which we have. So you can see the pictures of the pilot site below. As I said, in one of the goals and the objectives is to look at quantifying the carbon sequestration potential. So for doing that, we are looking at doing or gathering or capturing the environmental data on our pilot site. So we are looking at quantifying rainfall, right? Beginning from quantifying rainfall at our site to looking at the water quality and the quantity. Um, so we just started our monitoring of our environmental data from May 2020 will continue until until the end of this Carbon Connects project on the monitoring part. So the monitoring part, is into two phases. I would say one is the pre-revetting phase, or you can call the pre-revetting as the current site condition or the current condition of the peatland. So we'll be doing monitoring that up till roughly about September of 2020. And post revetting, as Derek said, the landowner has to be actively engaged in order to get the supporting payments. He has to be actively engaged in blocking the drains at a site so that he reactivates his peatland and allows the groundwater to come up to the surface. And by doing this, he allows his peatland to be wet all the time. And so we'll be doing that monitoring beginning September or October 2020 to the end of almost the end of the Carbon Connects duration. So we'll be looking at these both these phases, monitoring phases. I'll slightly go into the activities part. We have set up the rain gauge, very important rainfall data. Often we assume that, rainfall is not that much required to be collected at the site, but it's pretty important because we know that, it rains at one place and it doesn't at the other. So capturing rainfall data at your site where you are monitoring environmental data is pretty important. We are also looking at where the water table is, because we always we talk of a peatland being dry and a peatland being wet, and we always ask, do you know where the water table is? Do you know if your peatland is wet or dry? So water table is a big indicator of whether your peat is dry, whether your peat is too dry or too wet, or it's wet all the it's quantifies that aspect of the peatland hydrology, I would say. So, and then the water table depths are related to the the type of vegetation that could come up at your site, at your peatland site, strongly linked to the wetness and the greenhouse gas emissions from your peatland. So monitoring water table is pretty important. Besides that, we are looking at some water chemistry aspects. So we are looking at the redox potential typically and the pH. I mean, pH in simplest terms, when we say a peatland, people tend to ask you, is your, typically a peatland is an acidic, nutrient poor condition. So some might ask you, do you know if your peatland is acidic or alkaline or neutral? What's the pH? So we are looking at that aspect as well. We will be taking some, water quality data. Basically, we will be looking at, what is the dissolved organic carbon in the water, and that's the indicator of the carbon in the peat water. So we will be looking in the pre and the post revetting periods. Our other important, task is to look at what's the carbon in the current state of the peatland. Taking some peat cores from from the pilot site, and in the both phases, and we'll be looking at, is there any difference between the two conditions? We'll be looking at the bulk density and some other measurements. We are trying to work with other EU partners. We've just started working on can peatlands, soak up water, and could it be a flood attenuation tool? Could it absorb? You can think of peatlands as sponges. It soaks up the water and then slowly releases it. So could peatlands be acting as a flood mitigation tool? So we are looking at that. IT Sligo, they are working with the Pearl Mussel and with us. So we have a PhD student. She's working on, looking at what kind of vegetation is at the site and what kind of vegetation would be there once the drains would be blocked. So she's working on the site, and she'll talk about it in just after I finish now about her vegetation and beetle stuff. And then we have once again have VHL who have a site emissions tool. It is kind of a computer modeling tool, a user-friendly computer modeling tool, I would say. And it basically quantifies, what are your greenhouse gas emissions from your pre-rewetting conditions, that is your current site, your current state of your site, and the conditions once you block the drains and allow the water table to come up. What's the GHG emissions from the post rewetting phase? So this tool kind of quantifies that aspect as well. I'm now going to hand over to Poppy for explaining. She's a PhD student, so she's going to do a lot of experiments on the Carbon Connects pilot site and elsewhere. So I'll hand over to Poppy for the presentation on the slide.
Hello everyone, and thank you, Amay. So as Amay mentioned, I'm a postgraduate student in IT Sligo, and my collaboration with Carbon Connects is part of a wider research project. We're looking at the co-benefits of the Pearl Mussel Project, which, as Derek mentioned, is a results-based payment scheme. So for this year, I'm doing beetle and vegetation surveys on a number of grassland and peatland sites included in the Pearl Mussel Project. From these surveys and the information we gather, we hope to use these two biodiversity groups to investigate the relationship between the Pearl Mussel Project scores, hydrological integrity, and the biodiversity on these sites. These surveys will also be used to chart the changes in biodiversity on the peatland restoration sites as a result of rewetting. So I'd just like to say thank you very much to Amay and Carbon Connects for working with us and working together, because it increases our information on the whole site in total. So it's great. Thank you very much. I'll pass you back to Amay.
Thanks, Poppy, and thanks for this great introduction about beetles and the vegetation survey on the Carbon Connects and the other sites. So thank you so much. I'll take over from Poppy now. What essentially we all are doing is, you can we are puzzles. We are different puzzles of the peatland, and we are trying to put these puzzles together to complete the picture of the blanket peatland which we are working on. And as I said, LIT is working on the aspect of the environmental data and using the model developed by VHL to look at the GHG emissions. We have PMP, which is the Pearl Mussel Project, and IT Sligo working on the vegetation and the beetles survey. We have the private landowner, whom we are very grateful to for allowing us to work on his peatland site, and the Freshwater Pearl Mussel. We have Derek. So they are looking after the ecosystem services and the incentives which Derek talked about. So we are again, putting the pieces of puzzle together, and hopefully we'll be able to tell a story after the end of the project. Now I'm going to share some very preliminary results, but important. because we are talking of quantifying the amount of the carbon that this, that this site could sequester, based on the monitoring period and based on the changes in the pre and the post re-wetting period. So we started collecting rainfall on the May 20th. So the total rainfall, just to give you some numbers, collected from May 20th to June 25, didn't rain a lot during that period. So the total rain was around 67.4 millimeters during that time period. We have 4 water table wells at different locations in the peatland site. And we all know that within a peatland site, it's never homogeneous. We talk of the peatland heterogeneity within the peatland site. So it's very encouraging to see some of the water table depths, that some of the water table depths in the well 2, 3, and 4 were within 15 centimeters. As I said, this peatland site, is situated or located in a very heavy rainfall area on the western coast of Ireland. So we expect that from that water tables be close to the peat surface. We had one well which was probably located in a drier peat area, I would say, and then the water table was 40 centimeters below the peat surface. So that's the heterogeneity of the peatland site. And we started monitoring pH again. We still think the pH is acidic, because pH below 5, typically, we generally tend to call it acidic. 6, 7 is typically neutral. Above 7, we call that it's an alkalinity, or it's alkaline pH. So our bog is still, or our peatland is still quite acidic, we would say, based on the short monitoring. And we are going to continue this monitoring in the long term to really know what's the condition. So now here I'm going to show you just an example of the variability of the water table depth. So this is the well number 2, and remember, we are collecting water table depth every 30 minutes. So you probably have more than 20 water table depths readings on each day. You have lots of them. I cannot plot this data for 10 days and show it to you. It's too much to show. So I've just taken a water table depth on a particular day. So what you can think of is, if you see on the graph, the zero is actually the peat surface, the top peat surface. So the water table in the well 2 on June 23rd, beginning June 23rd, was about 0.4, 0.5 centimeters below peat surface. And it continued to decline until 3 p.m. or 3:30, 4 p.m. in the afternoon on that day. And we had a series of rainfall events as captured by our rain gauge. And what that led to is the water table came up from 4 centimeters below the peat surface. So at around 2 p.m., the water table was 4 centimeters below the peat surface. And it went on, it went coming up to the peat surface, and it went above the peat surface. And it remained there until the end of the June 23rd. And this was due to that we had so much rainfall events. We had continuous rainfall events from 4 p.m. until the night of around up till 11:30 p.m. At night. So we had continuous rainfall events, and water table remained there above the peat surface. So what we did is, we wanted to see if what results we are getting, are they similar to what other people have been getting, or are we somewhere else? So we looked at an Irish EPA research report. The researchers from the University College Dublin, they had published a research report. Rena Wilson, 2018, she's the lead author of this paper. So they looked at monitoring water levels on blanket peatlands and raised bogs in Ireland, different bogs. And that's, this is the map of Ireland. So they monitored a couple of the raised bogs in the Midland and the blanket bogs on the west coast of Ireland. So they found that the water levels were in the pre-rewetting phase, before blocking drains, and the water tables were between 0 to 60 centimeters below the peat surface. And once they started rewetting and the monitoring began after rewetting, the water tables came up to the surface, came near to the surface, near to the top peat surface. So they were 0 to 15 centimeters below the peat surface, and sometimes 10 centimeters above the peat surface on some days when it rained quite a lot. So, our water table results are pretty much, in the range of what's being monitored in Ireland. And they also had monitored pH, and our pH is quite similar. We had similar ranges of pH so far, I would say. So I would say we were in the ballpark or in the region of what's going on in the other peatland sites in Ireland. Now we are actually going to talk about the benefits of rewetting and the site emissions tool. This is developed by VHL, our lead partners in Netherlands. So I'm going to hand over the presentation part now to Jasper Van Bell, Dr. Jasper Van Bell. He's the developer of this tool. And so I'm going to hand over to him. Over to you, Jasper.
Yes, I think I'm now visible. You can hear me. The site emissions tool, we set this up for Carbon Connects. Basically, what we set out to do is to develop a tool to quantify the effects of rewetting peatlands on greenhouse gas emissions. And it needed to be suitable for scenario analysis, because that is typically the approach taken to assess greenhouse gas benefits of rewetting. And it also needed to be fairly simple, at least on the user interface side. It needed to be simple enough that one could use this without having loads and loads of background knowledge and all these processes that go on in these peat soils. What we came up with is an Excel tool, as Amé has told you already. And it has an input screen, it has an output screen, and it has quite a few screens that no user ever sees, where the actual calculations take place. And it's based on two things, actually. It's based on the guest system, which is a database of vegetation types and the water levels they occur at, and measurements, sets of measurements of carbon dioxide emissions and methane emissions. So that's useful to assess the carbon flows for different vegetation and groundwater level types, which are called greenhouse gas emission site types. Yes, I'm pronouncing this correctly. And this was developed by the Greifswald University in northeastern Germany. So that was an existing database that we used. And the other thing that we put in was IPCC Tier 1 calculations especially for the N2O flux. Nitrous oxide is a very potent greenhouse gas. So you ideally would really address this in any calculation tool. Just to give you a feel of the quantities we're talking about, methane is about 28 times as potent a greenhouse gas as CO2, and nitrous oxide is in the range of, I never know this by heart, but it's in the range of, I think, 268 or 258, something like that. So that is a very potent greenhouse gas. However, nitrous oxide emissions are not really directly related to water levels. usually, but are mostly the result of fertilizer application. So we use the IPCC's tier one calculations, so the standard calculations for countries to report on their greenhouse gas emissions to the IPCC, and put this into the Excel tool. And similar equations were also used to assess the carbon dioxide emissions associated with energy consumption for pumps and land management and so on. And finally, we put in also that you can do something useful with the biomass that you produce in a productive re-wetted peatland. I don't think AME uses this part, but other pilot sites in Carbon Connects have an objective to produce useful biomass. And if you, for instance, produce taifa, and you use this taifa as a building material, which is one of the options, then you would put away the carbon that is contained in this taifa biomass for let's say 20 or 30 years. So you could actually count this as a greenhouse gas emission reduction as well. So all these aspects are in, and so the user puts in a set of data in the input sheet, and then the calculations take place in the background, and the user can look at the output sheet to see what the results are. So Ame, if you could switch to the next slide. So this is part of the input tab in the site emissions tool. It's asking for some input data, the name of the site, total area, elevation, type of peat, the peat thickness, and the year that re-wetting started. Most of this data is used for calculations on the results. Peat thickness, for instance, is used to look at how much carbon is being emitted, and this is used. So we use the peat thickness to calculate the total amount of carbon in the soil, the carbon stock, because the explicit aim of this is to calculate creditable greenhouse gas emission reduction. So if you want to go to carbon crediting, you need to know how much carbon is actually in your system, because if you want to claim a reduction in carbon emissions, this is only valid for maximally valid for the amount of carbon that is in your soil. You cannot claim more carbon credits than you have. So then what it does, it asks you to put in the median groundwater level in summer, and this will then provide a first selection of the vegetation types that could be present at your site, and you select the most appropriate vegetation type. So for Utrecht, Ame has filled in the median groundwater level in summer was before re-wetting 25 centimeters below the surface, as you can see here, and the associated vegetation class is that of moist bare peat. After re-wetting, groundwater level will rise by some estimated 20 centimeters to -5 centimeters, so 5 centimeters below the surface. Then a vegetation class associated with that. Apparently the most likely vegetation in this case is that of wet small sedges with mosses. Can we go to the next one?
Yeah.
So this is the second part of the input. It asks for fertilizer application because it needs this to calculate nitrous oxide emissions. It asks for well, energy consumption for land management, what type of crop is being grown and what it's used for after rewetting, to be able to calculate whether you could also claim carbon credits based on the crop you produce. So go to the next one, please.
Yeah.
So these are then the results. As I said, it's a scenario based approach. The site emissions tool will calculate up to 2050 the estimated effect of rewetting. So it compares the rewetting scenario with the emissions in business as usual, which we call the baseline scenario. So the general approach is that the reduction in greenhouse gas emissions that you realize relative to the business as usual scenario, that is the amount of greenhouse gases that you have saved and that you could claim credits for. In this case, we see that the moist bare peat, it has quite a bit of carbon dioxide emission. This is for the entire site, so it's roughly 80 ton CO2 equivalents per year, and this is changed into a net CO2 sequestration of about 18 ton CO2 equivalents per year for this site, which is, I believe, 9 hectares. And you see that there is some nitrous oxide, or we calculate some nitrous oxide emissions in the business as usual scenario. So that is the current situation, and also for the rewetting scenario. This is basically, this is a baseline N2O emission resulting from vegetation growing on the field, and the most easily degradable parts of this vegetation after they have died will be broken down, and this will result in some nitrous oxide emissions to air. An important change that you also see is with methane. In the old situation, the moist bare peat with relatively low groundwater levels, there was almost no methane emission. But in the rewetting scenario, you see that there's quite a bit of methane emission, at least if you calculate this in tons CO2 equivalents per year. So the actual amount of methane being emitted is not that much, but because 1 unit of methane is roughly 28 or 30 times as potent a greenhouse gas as CO2 is. The small amount of methane that is being emitted has a relatively large climate forcing effect, leading to a total global warming potential of 42 that arises literally from the rewetting. You still have a net benefit
Jasper, are you there? We lost your voice, I think.
Yes, I'm back. I think my connection timed out. In any case, wrapping up these thoughts, despite the increase in global warming potential from methane being produced after rewetting, you still have a net benefit going from around 100 ton CO2 equivalents per year to around 46. What it also calculates is the time until all the peat is lost. And in the baseline scenario, this remaining 2 meters of peat would have been lost in approximately 600 years. And it calculates that this is increased to over 2,000 years after rewetting. And actually, the picture is even more positive than this, because this is basically a small bug that is still in the site emissions tool. It should have calculated that the time until all peat is lost is indefinite, because even though you still have some greenhouse gas emission, owing largely to the methane effect, these small sedges and mosses are actually net carbon accumulating vegetation. So that means the peat is being built up. It's increasing again after rewetting, but the site emission tool obviously is not quite dealing correctly with that as yet. So that's one of the things we'll be working on for the remainder of the project. And we're also working on building similar calculators for other ecosystem services associated with peatland rewetting. An important one is the effect on well, flood attenuation, as Amé has already been talking about, and actually Amé's work is a large part of that. So we want to build a similarly user-friendly interface to also quantify roughly the effects of rewetting on water retention in the peatlands. And we're also working on a tool to calculate nitrogen and phosphorus removal from surface waters using these marshlands, these mires, if you will. So that's what's still in store for the rest of the project. That's it, I think.
I think, yeah, we just have one more. We just put it.
There is one more actually. So yeah, there is the this is one of the outputs. The site emission tool, it provides outputs in a few graphical senses. So you get a graph of the emission distribution across the different types of emissions before and after rewetting, and it calculates this type of emission scenarios. So what you see here is a timeline of what actually happens. The green line shows the amount of greenhouse gas being emitted in the business as usual scenario, so the baseline scenario. The blue line is what greenhouse gas emissions you're left with after rewetting. And then the orange line is the difference between the two, and that is the amount of carbon credits you could annually claim in a crediting system. If you were in a situation where you had very, very shallow peat, you might actually exhaust all the carbon in the soil before 2050. And if in such a case, what happens is that the carbon crediting line, so the orange line, drops to 0. Or if you have a net carbon sequestration, you only can claim the net carbon sequestration. But after all the peat in the or all the carbon in the remaining peat has been credited, so you have reduced or prevented the emission of this carbon to air. After this time, you cannot claim any more carbon credits, because your baseline emission would have gone down to, well, theoretically 0. And I do believe this was the last one, right, Amé?
Yeah,
Okay.
thank you, Jasper. Thank you so much for this Greatly appreciate presenting this SETS tool. It's a pretty useful tool for all the Carbon Connects partners, and we have been trying to use this tool at our individual pilot sites. I'll take over from Jasper. Thank you, Jasper, for such a wonderful introduction to the site emissions tool developed by VHL. So thank you. Coming back, to what I've been talking about, the LIT site activities, and besides the looking at the carbon sequestration potential, as I said, we are working with the business model with the Pearl Mussel, and we also are working with designing. We already have designed, I should say. We recently designed an online survey. The goal was here to gain, the survey was designed basically to gain the perspective of farmers. What do farmers think the peatlands are, and what is their perspective on the climate change and greenhouse gas mitigation? And we were especially interested for the Irish parts. We were especially interested to know that what could be the feasible and the practical business models that could be implemented from now on the revetted peatlands, so that they could provide a secondary income source for farmers. And Derek talked about the ecosystem services as being one of the business models on the revetted peatlands. We have opened the survey from July 1. We'll keep this open for a while, for a month to go. So please spread the word. You can follow my Twitter account or the Twitter account of the Carbon Connects. We have the Carbon Connects tweeting about the project site activities of different EU partners, and it's been tweeted on the RDI LIT as well. So, for this, I would sincerely thank the Carbon Connects partners, their feedback on the survey, feedback from Pearl Mussel Project, some feedback from IT Sligo, and NUIG Galway. They are the Irish partners on another EU Interreg project, Care Peat. So we appreciate some of their feedback on this survey, and greatly say thank you to all of them. I'm just going to summarize. Basically, our summary is just we are working with different pieces of the puzzle and trying to put together a complete picture of the pilot site, so that we could learn from what's going on at the pilot site. So essentially, I would say, we are trying to put pieces. We are trying to characterize the site. We are trying to quantify some of the things, and will be then correlating whatever things we have monitored or whatever things are there. So essentially, as I said, water quantity, chemistry, vegetation, GHG, ecosystem services, beetles. So we are all trying to correlate this and trying to complete the picture. So, however, I do feel that there is a much more need to look at the long-term monitoring of these peatlands in context of the carbon sequestration potential, and what is their current state and how that current state could be improved by revetting the peatlands. As I said again, the site emissions tool is a very good tool to look at different types of vegetation, to explore different types of vegetation and the water table depths, and come up with the quantification numbers as what could be the potential GHG emissions from occurring at your site. So this is a very simple, friendly based tool, which is very useful. It could be validated with some of the measurements from the site, and that would be great if that is done. So that's what I would like to summarize my presentation. I will conclude my presentation beyond the slide. We sincerely thank EU Carbon Connects project and all the EU partners. We are all working as a team together. We really thank them. The LIT development unit, which I'm working with Seamus Hoyne, who is the head of the development unit of the LIT, and the wonderful staff there. the private landowner. And we need to sincerely thank him very big time, because he has allowed us to come on his peatland and allowed us to do the things we are doing. And we are very grateful to him for this help. I have been working with Derek and Patrick, who are both working on the Pearl Mussel Project. They are leading the Freshwater Pearl Mussel Project. So we're very thankful to them. Big thanks to Mark O'Connor. Mark and myself, we have been talking about since a long while on what data we need to monitor on the site. And Mark is the guy, who has done most of all the instrumentation set up in collaboration with all of us about what plans we need to come up to monitor the site. So big thanks to Mark O'Connor and Dr. Byrne and Poppy, her PhD student, and they've been very kind. They are completing essentially the picture that what we are trying to show. So gratefully say thank you to all of you for such a wonderful teamwork. And I would like to conclude my presentation. Once again, I would like to thank all of you. It's July, so it's holidays time for all of you, but whoever have turned up, thank you for sparing your time and coming for this webinar. So thank you very much.
Yes, as Amit said, thank you to everyone for your time. We've a couple of questions, and I'm aware that we ran over time and a couple of people have had to leave. And Jasper and Derek have been very kind to answer some of the questions within the chat function already, which is great that this function is there and that we've been able to use it throughout. So one of the questions we had got from Audrin, Derek had put an answer into that. So Finbar had asked in regards to the freshwater pearl mussels been identified with any other peatland regions within Ireland, or are they primarily located on the west coast as shown in the map? If Derek is able to answer that.
Yes, thanks. Yes, the 80% of the Irish population occurs within these 8 catchments, and that accounts for almost 30% of the total European population. But the other 20% of the Irish population occurs, I suppose, throughout the country. There's you can go from Dublin to Cork, and each catchment will have some pearl mussels. But the problem is that if they don't have recruitment, they are doomed to extinction, which is the case with pretty much all of or most of the pearl mussel populations outside of our top 8.
Excellent. Thanks very much, Derek. The other questions, if you have a look at the chat function that have been put in, have been answered there. So I just want to end there, because I know we're in 10 minutes over time, by thanking Jasper, Poppy and Derek, and in particular Ame, for their time this morning. It has been a really informative webinar, and it's great to see with peatlands within an Irish context have such a historical value and within our lives, that they've been continue to be used after transitioning into a new way of use, which is fantastic to see. So well done to you all on working in this project, and I certainly working with MA excited to see some of the results that are going to come out of this project.
Yeah, I would once again personally like to thank Darren and Derek and Poppy and Jasper for the valuable contributions. Sorry that we ran over time, 10 minutes over time, but greatly appreciate you all being there.
And also remember, if you'd like to know any more, you can look at the Carbon Connects website through, you can find a link online through Twitter or through Ame's Twitter handle as well. There's some links there. It's definitely worth looking up. Thank you, everyone, and take care.